I've done here for the independent samples t-test is I've given you, here's the t formula that we need to calculate to solve for t. But notice it has in the denominator this term, which is the standard error of the differences between the two means. So here, we're going to solve for the standard error here, but this has the term s squared p, which we must solve for here. So what I've done is I've laid out the equations that we need to calculate in order to solve for the t. And then also down here at the bottom you can see the sampling distribution for t. This is from the prior step in part 1 of the lecture, where we had an alpha 0.05 and two-tailed, and for df of 18 we have critical values of 2.101 and negative 2.101. Now as a review, if we get a t that is negative 2.101 or smaller, we're going to reject the null. Or if we get a t that is 2.101 or larger, we'll also reject the null. If we get a t anywhere in between those two values, the critical values, we will fail to reject the null. So let's go ahead and calculate the t and see what we get here. Starting with this, s squared p, recall that this is equal to a pooled variance. Okay, s squared p, that stands for the pooled variance. S squared is a variance and p stands for pooled. So here we have ss1 plus ss2 over df1 plus df2. Now this we did not calculate directly yet, so let's go ahead and do that. df1 is just equal to n1 minus 1, which is 10 minus 1 or 9. df2 is equal to n2 minus 1, which is also 10 minus 1 or 9. So here we're going to have 9 plus 9. And we'll find our sums of squares up here. So we have 160 for this plus 200 over 9 plus 9 is 360 over 18, or that is equal to 20. So the pooled variance is equal to 20. Next we're going to use the pooled variance we just found and plug it into this formula here, the standard error of the difference between the two means. So here we have the pooled variance is 20, so 20 over n1. Now recall that n1 is the sample size for the first group, or 10. So we have 20 over 10, and then we have that once again, 20 over, now the sample size for group 2, which is also 10. That's equal to the square root of 2 plus 2, or the square root of 4, which is just equal to 2. Okay, so the standard error of the difference between the two means is equal to 2. Okay, now we can solve for t. So here we have m1, which is equal to 65, and m2, which is 59. So we'll write here 65 minus 59. And the standard error we found previously, that's equal to 2. So this is 6 over 2, or 3. So our test statistic is equal to 3, our t. So let's go ahead and compare that to the critical values and see where it lies. I have a t of 3 that I calculated. My critical value is 2.101. So notice here that my t of 3 is beyond the value 2.101, so I will reject the null hypothesis here. Recall that the null hypothesis stated that the population means for A and B were equal. I am rejecting that, and now I am saying I'm going with the alternative, which says that the means are not equal for the two groups. Okay, so what I could say here is, if the means are not equal, I look at these two sample means to see which group was higher. So notice that study method A with a sample mean of 65 is higher than study method B with a sample mean of 59. Since that result was significant, since I rejected the null hypothesis, I will go ahead and conclude that the people who used study method A had significantly higher scores than the people who used study method B. Okay? So I'm just going to shorthand that for the purpose of our video here. But B was significantly higher than A. Okay, and here we've got For APA format, we're going to have T, our test that we used. Then next we put degrees of freedom in parentheses. And our degrees of freedom, if you recall from part 1 of the video, was 18. Our T value is equal to 3. And then we have P, and we had an alpha of 0.05. Since we rejected the null, this P is less than 0.05. So this is our statement for write-up. Now once again, I shorthanded this here. B was significantly higher than A. To be more appropriate or more formal, we could put the people who use study method, B. Whoop, I got an error here. Excuse me. I have to make a correction. Hopefully you caught that. It's not that, was B higher than A or was A higher than B? Let's take a look. B, 59, A, 65. What should it be here? It should be that study method A is significantly higher than study method B. So I'm going to go ahead and correct that. Okay, and that's it. Everything else holds. Okay, so this concludes the example for the independent samples t-test.